Hello students. Okay, we're going to continue with gradient in this video. Now, sometimes you are given some points that lie on a straight line, but not the straight line itself, and you don't actually have the line drawn on a grid. So what we're going to do here is, given the coordinates of 2 points, we're going to give you the gradient formula, or find the gradient formula, so you can actually just substitute into the formula and find the gradient without actually having to draw the line or plot the points. Okay, so to start with, here we've got a grid, and I'm going to undo what I just did. And we've got 2 points on the grid. We don't know their coordinates because this rule is going to apply for any coordinates. And there's the line that passes through those 2 points. Okay, so the coordinates of this point, because it can be any point at all, we'll call them just x1 or x sub 1 and y1 or y sub 1. And you can probably guess what the coordinates of the other point are going to be, just x2 and y2. So we want to find the gradient of the line that passes through x1, y1 and x2, y2. Okay, so we draw the triangle, the right angle triangle. And the rise is that distance, and the run is that distance. And to help us actually work out a formula for that, we need the coordinates of that point just there, which turns out to be, it has the same x coordinate as that point, because x measures how far you are from the y-axis, so that distance and that distance is the same. So these coordinates match, and similarly the 2 y coordinates match, because they tell us how far we are above or below the y-axis. So that's got the same height as that one. So coordinates of that point are x2, y1. Okay, let's go ahead and develop the formula from that. So rise over run, where rise is just the change in height, which turns out it's just going to be the difference in the y coordinates, because height is measured by y. So this y coordinate is y2, this y coordinate is y1, and the difference between those two is just going to be y2 take y1. And the change in the horizontal distance is just the difference between these two, which is the length of that line segment, and that's just the difference in the x coordinates. So the length of that is going to be x2 take x1. So change in height over change in horizontal distance is just the change in the y values, so the difference in the y values over the change or the difference in the x values, which is y2 take y1, that's the rise, over x2 take x1, which is the run. And there you have it. That's the formula for the gradient of a line that passes through the points with coordinates x1, y1, and x2, y2. So let's go ahead and show you how we'll actually do this in practice. Okay, so there's our formula, and there's the coordinates of the 2 points. So the first decision we have to make is, which point are we going to call point 1 and which point are we going to call point 2? Well, normally you want point 1, if possible, to have the larger coordinates, because you're subtracting therefore big number minus small number, you're going to avoid negatives. So if possible, choose the one with the larger coordinates. Sometimes it doesn't make any difference. In this case, it's fairly obvious that if I make this one x2 and y2, those numbers are larger than these two, so the coordinates of that point are x1 and y1. So step 1, identify point 1 and point 2, and write the general coordinates underneath the numbers. Okay, the next step is to write the formula, and you'll be given this in my class. You'll be given this on your formula sheet, so you don't need to memorize it. Maybe your teacher's not as nice as I am, so you might have to memorize it. Okay, the difference in the y coordinates. y2 is 7. Subtract y1 is 5 over x2 is 11, x1 is 3. We'll put that on the same line to keep space. 7 take 5 is 2. 11 take 3 is 8. And therefore, the gradient is 2 over 8. And of course, we always try to simplify if possible. So 2 goes into 2 once. 2 goes into 8 4 times. And the gradient in simplified form is 1/4. Okay, stop the video. Have a go at the second question, please. Okay, welcome back. Let's see how we went. Now this one's a little bit harder to figure out which one to call point 1 and which one to call point 2. So I might just go ahead and make this one just for something different. I might make this one x2, y2, and x1, y1. So it really does help to actually write the those variables underneath the numbers. Then it's just a matter of substituting. Always write your formula. Even if you've written it 1,000 times before, write it one more time. That's how we do mathematics. We write the formula, we substitute. So y2 take y1, 2 subtract -3 over x2 take x1, -1 subtract -5. Okay, now if I'm subtracting a negative, that's the same as adding a positive. Subtracting a negative is the same as adding a positive. And that becomes 2 plus 3, whoops. 2 plus 3 is 5. And -1 plus 5 is 4. And therefore, the gradient of the line passing through these points is 5/4. So once you learn how to do this with the formula, not that difficult. The main thing is if you're going to call that point or that value x1, this one can't be y2. You have to be y1. So point 1, the subscript is 1 on both of those, and that's point 2. It has to be x2 and y2. Okie dokie, we'll go ahead and practice finding gradient of some lines given 2 points on the line.